Example 5. Write the following equations without logarithms. In part A, we have the equation that logarithm of A equals logarithm of B plus 2 times logarithm in base 10, of course, of C. Now, if I want to replace it by an equation without logarithms, I have to aim for expressing both the left-hand side and right-hand side of this equation as a single logarithm. So I will use the logarithmic laws to do just that. Left-hand side is already a logarithm, single logarithm, so I will leave it without any change, but I will concentrate on the right-hand side. So what do I have here? I have logarithm of b. Let us leave it without change for now, plus, and here I can use the third logarithmic law, since this is the product of a number and a logarithm, so it should be the logarithm of the power. So it's the logarithm of c to the c squared, so c to the power of 2. Okay, now logarithm of a equals, and now I have the sum of two logarithms, and the sum of two logarithms is, according to the first logarithmic law, it's the logarithm of the product, so it's the logarithm of the product b times c to the power of 2, like this. Now, this is the situation that I aimed for. I have on the right hand side and on the left hand side I have one single logarithm. And since logarithms are one-to-one functions, it means that if two logarithms are the same, then also the numbers they are taken from must be the same. So it follows that a equals b times c squared. And this is the answer to this part. So what we did, we wrote the following equation, the equation here, without logarithms, and this one is equivalent to this equation. Of course, the obvious requirements have to be satisfied or met, and they are the following: both a, b and c have to be positive. So a has to be positive, b has to be positive, and c has to be positive for this to be equivalent to each other. Okay, now let's move on to the second part, part B. We have logarithm in base 2 of m equals 3 times logarithm in base 2 of a minus 2. Okay, so this one is a little bit harder. So again, let me aim for having single logarithm on the left hand side and a single logarithm on the right hand side. On the left hand side, this goal is already met, so there is just, I will leave it like as it is, so it's logarithm in base 2 of m equals, and here let me use the third logarithmic law to replace this first term as the logarithm in base 2 of a to the power of 3, so it's the logarithm of the power is the product of the power and the logarithm of the base, minus, and here I have number 2. You may remember that there is this simple rule that n can be written as logarithm in power of in base of a to the power of n. Okay, there is this simple rule which we can use. It has to do with the third law of logarithms, because this is actually n times logarithm in base a of a, which itself is just 1, so it's n. Okay, so instead of having 2, I can rewrite it as the logarithm in base 2 of 2 to the power of 2. Okay, 2 to the power of 2 is just what I need. Base is a, in our case it's 2, and coincidentally n is also 2, but this and this should be the same thing. Now I have the difference in two logarithms, so I can use the second logarithmic law to rewrite the right hand side. So let me copy the left hand side without any change. So it's the logarithm of in base 2 of m equals, and now I should have the logarithm of one single thing, and it's going to be the fraction. It's the logarithm in base 2 again, and the fraction will have the numerator of a to the power of 3 divided by or over 2 to the power of 2. But what is 2 to the power of 2? 2 to the, well, I could have used a pair of brackets here. 2 to the power of 2 is just 4. Okay, so this is the final form for the right hand side. And now you see, we have the equality of two logarithms in the same base 2. Now, since the logarithmic function is 1 to 1, we can again draw the conclusion here that m must be equal to a cubed over 4. Since these two logarithms are the same, then also the numbers they are taken from must be the same. And hence, this is the expression that replaces this logarithmic expression but doesn't use logarithms at all. And that's it for this exercise.